guys, my name is Sharon Robert, matrix number 230814, and today our group will be presenting about elemental particles. Everything around us, including this phone, water bottle, and even you are made from tiny particles. Ordinary matter are made from protons, neutrons, and electrons. Together, they form atoms and all the things we see in periodic table. But these particles aren't enough to explain everything. Neutrinos are needed for nuclear reaction in stars, and photons allow charged particles to interact through light and electricity. These particles interact through four fundamental forces, which is strong force, weak force, electromagnetic force, and gravitational forces. This interaction decide how particles combine, why atoms are stable, and how all elements are formed. Now you see guys, elementary particles are grouped into leptons like electrons and neutrinos, and hadrons like photons and neutrons, which are made of quarks. By studying elementary particles and their interaction, we can understand matter from atoms to the universe.
Have you guys ever wondered what's something that's stopping matter from falling apart? There's no glue, there's no tape, but it's something way stronger. Meet the strong interaction, the strongest force in the universe. Strong interaction holds nucleons together to form a nuclei, and it holds quarks together to form a nucleons. What is quarks? Quarks make up by protons and neutrons inside atoms. Quarks stick together by throwing particles called gluons at each other like super strong cosmic glue. This force also holds protons and neutrons together in the nucleus, even though protons want to repel each other. Without the strong interaction, matter and everything around us would not exist.
Next, I'll explain the weak interaction. Weak interaction is one of the four fundamental forces in nature. It is responsible for radioactive decay, such as beta decay. Through weak interaction, a neutron can change into a proton. This process is important in nuclear reactions. Weak interaction is also involved in production in the sun, where hydrogen atoms combine to produce energy. This force acts as subatomic particles and works over the shorter distance. Although it is weaker than strong force, weak interaction plays a crucial role in the universe. Wait. But what about the force we use in our daily life?
That's the electromagnetic force that makes everything in your daily life works. Have you ever wondered how does your lights turn on, why does your magnet stick, and how does your Wi-Fi works? It's all because electromagnetic force. This force happens between tiny particles called electrons and protons. Think of them like tiny magnets. Opposite charges pull together and the same charges push away. This invisible push and pull keeps electron moving in around tiny center, so it helps atoms to exist. Without atoms, nothing in this world would exist either. So, next time you switch on light, playing with your magnet, or even connect with your Wi-Fi, remember, thanks to electromagnetic force. In modern technology, quantum numbers are being used in smartphones and computers, whereby the movement of electrons in microchips depends on their quantum state. On the other hand, quantum number are also important in quantum computing, where the particle spin is being used to store information. In conclusion, quantum numbers are very essential to help create a faster and smarter technology in our daily life.
Why is it that when we drop our phone, it always falls down and never gently floats back up? That happens because of gravitational interaction, one of the four fundamental interactions in physics. Gravitational interaction acts between all objects that have mass, and it is always attractive. Although it is the weakest fundamental force, it has an infinite range and becomes very important at large scales such as planets and galaxies. Gravity explains why objects fall to the Earth and why planets and satellites stay in their orbits. It is described by Newton's law of gravitation, which depends on the masses of objects and the distance between them. At the particle level, gravity is linked to a theoretical particle called the graviton. So, even though gravity is weak, it plays a huge role in shaping our universe. Thank you.